I'm going to record the quiz for practice solutions. So that way, all my online students and also on my on-ground students can go back and see how we're solving this quiz, how we're going to prepare for your actual quiz. Okay? So here we have complex numbers. And the first question, we have two examples. And here we have to simplify these radicals and we have to leave it with I. So if you remember, complex numbers are numbers which are square root of negative numbers. And every time you see square root of -1, that's going to be I. And if you see, okay, I'll stop there. I'll explain that later on for another questions we have. So we have square root of -1. We're going to replace it with I. So we're going to start with number 1. The first example is square root of -196. I'm going to rewrite that like a square root of 196 times square root of -1. And then the square root of -1 is going to be I. And I'm going to take square root of 196. It's a perfect square. And that's 14 times 14, so it's going to be 14 I. And that's all what you're doing. You're just replacing the square root of negative with imaginary number. Okay? And this is how you do it. So let's do the other one the same way. Let's do the next one is square root of -71. So again, we're going to do square root of 71 multiplied by square root of -1, which is going to be the I. And then square root of 71 is not perfect square. So I'm just going to keep it like that. Square root of 71. And then I'm going to put I. Now, there is an unspoken rule, and I'm going to put I in front. You have to put I in front, and I'll explain that. So there is unspoken rule for I. If you have number I, you put I in the end. If you have square root, you put it in the back. I'm sorry, if the square root goes in the back after the I. Like what's happening if I have, for example, square root of, let's say square root of 8. So I'm just going to make another example. So if I have square root of -8, that's going to change as a square root of 8 and square root of -1, which is the I. Now 8, I can break it down. So 8 is what? It's not perfect square, but you can take something. It's a factor of perfect square, half perfect square factor. So it's going to be 2 times 4 is 8, right? Now square root of 4, it's a perfect square, and square root of 2 is not. You can just stay there. So I'm going to change square root of 8 is going to be, so square root of 4 is 2, and square root of 2 stays there. So 8 is actually 2 square root of 2. And then you need to put the I. So in this case, when you have number and square root, I go between them. So it's going to be 2I square root of 2. So the rule is I goes after number, after whole number, and I goes in front of the square if there's a number with square root. And the reason behind it is because square root usually, when you write square root, sometimes if you put I behind, sometimes it could look like I is inside the square root, which is something different. So that's why, to make sure you don't have that confusion, you put I in front of the square root. Okay? Everybody understanding this?
Quick question.
Yes.
On the first example where their answer was 14I, you got rid of the square root symbol?
Yes, I took square root of 196. So you can use it in the, I mean, I know it's a perfect square, I know the answer, but you can just put it like that. You can just go to symbol up and just put it square root. And you put, what was the number? 196. Like that. And it's going to give you the square root. It's 14. Okay? Now,
so when it's a perfect square, you don't keep the square root symbol?
Yes. Yes. Like if I have square root of 71, the square root of 71 is 8 point something. See, obviously it's not a perfect square. Okay? And again, if I do 8, square root of 8, let's see if it's going to simplify it. The square root of 8 is also, see, the square root of 8, if you can take it out, if you can get out the square root something, see, it's 2 square root of 2. Okay? So you can use symbol up to simplify it for you.
Yes, I'm just trying to understand when you use the actual symbol and when you don't.
Okay, so this is how that goes. If inside the number it's a perfect square, there is no square root left. Because if it's like square root of 4, for example, square root of 4 is just 2. There is no more square root, right? Because 2 times 2 is 4, okay? But if I have square root of 3, 3 is not perfect square, so that's why 3 is going to stay with the square root. Okay? Make sense? Okay, is there any more questions? I see thumbs up. Okay. Okay, so any other questions? Everybody good? Okay. So going back to my examples here, quiz for practice. So that's how you do the first one. When you have square root of negative, you're going to replace the negative, is going to give you the I, and then you're going to take, you can use single up to take square root of that number, and you're going to see if it's perfect square, or you can break it down, or you can just stay like the way it is, okay? So that was number 1. Then you're going to go to number 2. Okay. Number 2, we have make it bigger like this. Okay, so for number 2, we have to identify which one is the real, which one is the imaginary part, right? So that was, oh, why is moving like that? That was really easy. So remember the complex numbers, they have this form. They have this rectangular form or standard form A plus BI, right? So the first part with no I is the real component, and the part with the I, it's imaginary component, right? So just looking at the given examples, what you need to do is just say what is real, what is imaginary, right? Okay, I see some answers already popping in my chat. So let's do the first one. That's right, Marcel. So looking at this, the first number is real and the second is imaginary. So always make sure you connect the imaginary with the I. So what you need to write here, the real component is -2, and the imaginary is gonna be 4. That's it. That's all what you need to write. What is the real, what is the imaginary, okay? Now let's go ahead and do the next one. The next one is 39. So obviously I have imaginary component, but I don't have real. So what is the real? What is the real component here? There is none. What is the number for none?
It's 0.
It's 0.
Real is 0. Imaginary 13.
Good job. The real is 0. The imaginary is 13. Good job. That's it. Okay. Then the next one, we have the number 19 only. So the other one I can write it 0 plus 39. So there is invisible 0. Now for this one, what is the real component?
19.
19.
19 is the real. And what is the imaginary?
0.
The imaginary is 0 because there is no 0, there is no number with I. And so here is invisible. I can just put plus invisible 0I, right? So the same way you have invisible 0 in front of the 39. Okay? So that's how you do it, nothing else. You just have to differentiate which one is the real, which one is the imaginary part. Okay? So that was number 2. Any questions? Okay, then we're going to number 3. We have 2 examples here. And number 3, we have to simplify the power of I. Okay, if you remember, we talked about the power of I last time. So there's a little, we watched the video when you have, you're going around, you rotate, right? Remember that? But okay, let's stick with this. I to the 0, what is I to the 0? I to the 0 power is 1. Then I to the first power is I square is -1, and I cube is going to be -I. So these are the 4 values you're going to use. And everything else is going to just kind of alternate. It's a pattern, right? So the answer is going to be one of those 4 answers. Now, how you know what it is? You're going to divide the given exponent, 123, you're going to divide it by 4. And the remainder is going to give you one of these 4 answers. It's going to be which one of those 4 is going to get. You're going to get. So I'm going to divide 123. I'm going to divide it by 4. And that's 30, right? Okay, so it's 30. So 30 times 4 is 120. And the remainder is 3, right? So if the remainder is 3, that means I have this case here. I cube is going to be -5. That's my answer. But this is how you show your work. So I to the 123 equals I to the 4th, and then to exponent 30 times I cube. And then here, I to the 4th is 1. So I'm going to get 1 to the power 30 times I cube. And then I to the 30 is, 1 to the 30 is also 1. And you're going to get I cube is -1, -5. Sorry. So this is 1 and this is -5. And when I multiply them, I'm going to get my answer, -5. Any questions? So technically, the remainder is going to tell you which one of those 4 values you're going to have for final answer. Okay, so let's do the next one. In the next example, we have negative exponent, -72. So what you're going to do here, we can flip it over. So it's going to be 1, or make it positive, over I to the 72, positive 72. So now here, we're going to do the same with 72. We're going to divide 72 by 4. And that's going to be what? It's a whole,
18.
it's exactly 18, right? Okay. So you're going to get 72 with remainder 0. Now, if the remainder is 0, that means my answer is going to be 1, right? But I need to show the work. And because also it's in the denominator, you have to be careful. You have to show your work. So it's going to be 1 over I to the 4th, and then to the 18 times I to the 0. Now this is 1, and this is also 1. So I'm going to get 1 over 1, and my final answer is 1. Okay? Any questions?
Is it the same if you have a remainder left over and it's negative like that?
Okay, so if you have remainder left over, then you have, if it's negative, if this is, so let me give you all the possible cases. So I'll show you if it's negative, what are the cases. Yes. And yes, Darius, this is the rule. You always divide by 4 because the pattern is repeating 4 the same values. Because you have only 4 values different and they're repeating. That's why you always divide by 4. Okay, so I'm going to make up another one where the remainder is going to be something else. So if I have I to the -73, oh, this is going to have remainder 0. So in this case, if the remainder is 1, you're technically gonna get 1 over I, right? I to the first. Now, if you have I to the first, just 1 over I, you have to treat it as dividing complex number. So you're gonna multiply by I up and down. Okay? And that's gonna give me I over I squared is -1. So it's gonna be negative I. So 1 over I is gonna be the same as negative I. Okay? Now, I'm going to write all the different cases. So if you have remainder 0, if the remainder is 0, the answer is 1. If the remainder is 1, the answer is -5. Then let's do the remainder if the remainder is 2. If the remainder of the division is 2, then you're going to get 1 over r squared, right? And r squared is -1, so it's going to be 1 over -1, and the answer is -1. Okay, so if you have negative, this is the case when you have negative exponent only. So if you have a remainder 2, the answer is -1. Okay, so it's a little shifted, a little different. And then the last one, if you have remainder is 3, so if the remainder is 3, then you're gonna get 1 over r cubed, which is going to be 1 over -I, right? And you're going to treat it the same way with the first one. You're going to multiply by I up and down, and that's going to give me I over negative, and then I squared. I'm going to rewrite it so I can have it step by step. And then you're going to have I over negative and -1, which is positive, and the answer is going to be just I, positive I. Okay, so if the remainder is 3, you're going to get I. So these are the 4 values if you have negative exponent. Okay, any questions on this? Everybody understanding that? Okay, going to the next one, number 4.
Just working on mine. I was
Yes?
copying that down on paper.
Oh, okay. I'm going to save this and you can have it. Yeah, here you go. So the rule is you always divide by 4, and the remainder is going to give you what is the answer. Now, when the exponent is negative, you have to be careful. It's a little different. So technically, for remainder 0, it's 1. For remainder 1 is -5. For remainder 2 is -1. For remainder 3 is I, if the exponent is negative for I. Okay? You got it? Okay, the next one we're going to go is we have to simplify. You have to do all these operations. And the way to do that is we're going to start with addition, subtraction, multiplication, division of complex numbers. So when you have plus, when you have to add complex numbers, you're going to take off the parentheses first. So because you have plus here, just ignore the parentheses. So I'm going to copy everything the way it is. -4 plus 3i, everything stayed the same, plus 5 minus 4i. Okay? And then after you take out the parentheses, you're going to combine like terms. So you're going to combine number with number and I with I. Okay? So when you do that, you're going to get what is -4 plus 5 is 1. And then 3 minus 4, we're combining the I, is going to be -1i. And that's going to be my final answer. You get a complex number, which is 1 minus 1i. You don't have to put the second I here, so you can write it like 1 minus I also. It's the same. But the 1 in front, the real component, has to stay like that. It's important that you keep the first one. Okay? The next one, any questions about addition? Okay, the next one is subtracting complex numbers. So when you subtract, you have to distribute the negative invisible 1 in front. So I'm going to multiply negative 1 times 3, negative 1 times negative 5i. So we're going to get 8 minus 7i. We're going to copy that. And then it's going to be minus 3. And minus times minus is plus 5i. And then from here, we're going to do the same. Number and number, I and I. So 8 minus 3 is going to be 5. Negative 7i plus 5i is going to be negative 2i. And that's my final answer. That's how you subtract complex numbers. So pretty much you're doing the same way, adding, subtracting any real number. Just here you have two components. You have real component and you have imaginary component. Okay? Any questions? Okay, going to the next one, which is multiplying. We're going to multiply complex numbers. So when you multiply, you have to do FOIL. You're going to do first and first. 1 times 2 is 2, so that's F. Then you're going to do the outside. 2 times negative 4 is negative 8, and you have the I, so that's O. Then you're doing the insides. Negative 7i times 1 is negative 7i. And then you're doing the last two, negative 7i and negative 4i. So negative times negative, it's positive. 7 times 4 is 28. And I times I is I squared. And this is the letter L for the FOIL. Okay, so you're doing first, outside, inside, and the last. Okay, after you multiply your FOIL, you're going to replace I squared with what? What is I squared? Negative 1. That's right. We're going to replace I squared with negative 1. And then you're going to simplify. I can just combine I and I right now. So I'm going to be 2 minus negative 8 and negative 7 going to be negative 59. And then 28, positive 28 times negative 1 is negative 28. And then you have to combine number and number. So 2 minus 28 is going to be negative 26. And then minus 59. And that's going to be the final answer. That's what you get. Negative 26 real component and negative 15 imaginary component. Okay? Now, let me ask you something else, if you remember from last time before you go to division. Now, looking at the number negative 26 minus 59, can you tell me which quadrant is that number? If I grab the number, which quadrant is going to be?
3.
That's right. Good job. It's going to be quadrant 3. Good job. That's right. Okay, we're going to talk about that in number 5 in a little bit, okay? But now that's what you need to do. The multiplying the two numbers, we need to FOIL, then you have to replace I squared negative 1, combine I, and then combine number, and that's it. Okay, then you're going to go to the next operation, which is division of complex numbers. And when you divide two complex numbers, we're going to multiply by conjugate of the denominator. So I'm going to multiply. Yes, Mark, you can do box method also for multiplying. Okay, so we're multiplying here by conjugate of the denominator. So what is the denominator? 3 minus 7i. What is the conjugate of that? Do you remember what conjugate means? You need to change the sign in the middle. So what is the conjugate of 3 minus 7i? What is it? Opposite. That's right. So it's going to be
plus.
Yes, 3 plus 7i. And I need, so from the bottom I get opposite. I get the conjugate, 3 plus 7i. And I have to multiply up and down by 3 plus 7i. Because I don't change the fraction. I just gonna expand it,
You
multiply by...
don't change the 3 to negative?
No. You change, yes,
Okay.
you're not changing. You're just changing the sign between them. Changing the sign of the imaginary component only. Okay? So that was a good question. Everybody understand we're changing only the sign for imaginary component. The real component stays the same. Okay? So now we have to FOIL up, FOIL down. We have to do that for the numerator and for the denominator. So let's do that. We have 5 times 3, 15. 5 times 7i is plus 35i. Then negative 9i times 3 is negative 27i. And then negative 9 times positive 7 is negative 63i squared. So that's what you have in the top. Then in the bottom, you have to do the same. FOIL. 3 times 3 is 9. 3 times 7i is positive 21i. Then the inside are going to give me negative 21i. And then when I multiply the last two, it's going to be negative 49i squared. Okay? So what do I do next? I need to replace the I squared with negative 1, right? Whatever you see I squared, you replace it with negative 1. Okay, also in the denominator, you combine I and 9 and they cancel out. It's 0i, there's no more I. And that's why you multiply by conjugate, because when you multiply two conjugate numbers, there is no more I. You're going to get a real number. So always when you multiply two conjugate complex numbers, you're going to get a real number. That's the goal here. That's what you want to get. Okay, and then after I replace I squared with negative 1, I'm going to combine the i's in the top. So I'm going to keep 15. And I'm going to combine those two. So what is 35i? So I need to subtract 35 and minus 27i. So that's 8i. And then negative 63 times negative 1 is going to be plus positive 63. And then in the bottom we have 9 plus 49, right? Because negative 49 and negative 1 is going to be positive 49. Then after that, we have to combine the real components. So adding 15 plus 63. So I have 15 plus 63 is 78. And then you bring down the plus 8i. And then over, now when you add 49 plus 9, you're going to get 58, right? Now, I can just put everything over 58, or I can split it to get the rectangular form of the number. So I'm going to write it like this, over 58 and over 58. Now, we're doing that because we have to simplify it. We have to get the real component and the imaginary component. So we're going to split it, and then you're going to reduce. Now, I can divide up and down by something, right? So when I divide 59 by 2, I can divide by 2, it's going to be 29. So I'm just reducing. So this is going to be 29. And this is going to be 29. And I divide 78 divided by 2. It's going to be 39 in the top. And when I divide 8 by 2, it's going to be 4. So my final answer, reduce, simplify, break down like a rectangular form of the complex number where you have real component, imaginary component, is going to be 39 over 29, that's the real component, plus 4 over 29, that's the imaginary component, and that's why I have to put the I next to it. Okay, so this is my final answer when I divide those complex numbers. Okay, any questions on this?
Is it 4i over 29 or 4 over 29i?
Doesn't matter in this case. It doesn't matter. You can put I in the end or you can put I in the top. It's still the same. Thank you for asking that. Yeah, that's a good clarification. Yes, it doesn't matter. Okay, any other questions? Okay, the next operation we're going to do is square. So we're going to square complex number. Okay, and we're going to do it the way we're going to pretty much distribute the like squaring the number, which means multiply the complex number 2 times by itself. So we're going to multiply 3 minus 5i multiply by 3 minus 5i. So this is one way of doing it without going to polar coordinates. Okay, so because if you have higher exponent, you can use polar coordinates, and there's some formulas that you can use, but this is the easier way to do it. In this case, if it's only square. So we're going to multiply 3 minus 5i, 3 minus 5i. You multiply the number by itself, the same number, 2 times, because that's what the square means. So you're doing the same like the one before when you FOIL. We're going to multiply 3 times 3 is 9. Then you have 3 times negative 5i is negative 59. Then you're going to do the inside is negative 59 again. And then we multiply the last two, it's plus 5 times 5 is 25 I squared. Then you're going to replace the I squared. We're going to simplify. So the I squared is negative 1. So I'm going to combine those two. So we have 9 minus 30i and then minus 25. Because positive 25 and negative 1 when you multiply is going to be negative 25. So now what you're doing, you need to subtract 9 minus 25. And that's negative 16 minus 30i. Always when you write a complex number, always write the real component first and then the imaginary component on the end. Okay? So that's it. Any questions so far? Okay, then you're going to go and do the Argand diagram. And the Argand diagram was the graphical representation of a complex number, right? So how you do that? You're just going to go to the real component. So this is your real component axis, and this is the imaginary component axis. You're going to see the real is 4, the imaginary is negative 5. So you're going to go 4 to the real, to the x, and negative 5 to the y, and wherever they meet, you're going to put a point, and then you're going to connect that point with the 0, 0, and you're just going to make a little arrow there. That's it. So that's the the visual representation of the complex number 4 minus 5i. Okay, everybody understand that? So that's all.
I don't
Yeah.
see an example like this on the actual quiz.
Okay, so even better. Okay, that's fine. And then we're going to do the next one, which is the last one, where we have to represent, in the Argand diagram 3 complex numbers. One of them is going to be, I'm going to use this number. Then I'm going to draw a different color, the second number. And then I'm going to add those 2 numbers, and I'm going to have another one which I need to put everything in the same graph. Okay? So we're going to have, when I add those 2 numbers, I need to take off the parentheses, which is 4 minus 3i, and then minus 2 minus 5i. I'm going to combine them, so number with number, I with I. So that's going to be 2 minus 8i. And this number, I'm going to draw it in different color on the graph. So let's say this is my third answer. So the answer of the addition. So we're going to do that. We're going to grab the first one. So let's start with the purple. Oh, I don't know. So I'm going to do 4 minus 3. So 4 and then minus 3 is going to be here. That's the first complex number. Then I'm going to draw the blue one, which is negative 2 and negative 5. So they meet over here. And this is my second number. And then I'm going to draw the green one, the answer for when you add those two. So technically here we're going to see graphically how when you add two complex numbers, where is going to be the result. And that's what you're going to do next week. Next week we're going to talk about adding, subtracting vectors. Okay? So we're going to graph also 2 and negative 8. They meet over here. And this is going to be the resultant vector. So next week we're going to talk about vectors, which are like graphical representation of forces in physics. And also see these are the graphical representation of complex numbers. So you have we're going to talk about more about this next week, where you have vectors and we're going to do adding, subtracting vectors. See here, when I add those two vectors, it's going to be like parallelogram like this. Okay? But that's going to be next week. Nuclear decay, yes. Okay. So that's conclude pretty much the practice quiz for this week. You guys make sure you submit your quiz by Sunday. Quiz 4 is due by Sunday, 11:59 p.m.
Oh, Dr. Ian